Hello everyone, welcome to this new tutorial, which is basically the analysis of a Skew plate. So first of all, we'll rename this model. Put the name as linear since it's the first analysis that we'll be doing. Then create a part, and the name of the part is plate. Uh, the shape is kept as shell, and the approximate size is 4. Press on continue. So over here in the sketcher, we arbitrarily create a rectangle. Now we delete the constraints, press on done. Now what we want to do is we want to keep the two vertical lines and put the constraint vertical over here and over here, and these two horizontal lines will be made parallel. Press on shift and done. Now we'll do the dimensioning. This vertical line will have a value of 0.4, whereas for this horizontal line we'll choose the two vertices and put the value as 1. Now we want to put the angle over here instead of 90 as 60. Press on OK. Now press on done. So next what we do is we want to create a material. Double click on material and put the material name as metal. Over here put the elastic option, and the Young's modulus is 30 e power 9 and the Poisson's ratio is 0.3. Press on OK. Now we'll create a section, and the name of the section is plate section, and the category would be shell. Press on continue. Over here we choose the section integration type as before analysis, and the value that we put is 0.8 e to the power minus 2, and press on OK. Now we have to assign the section proper definition, and to do that we expand this plate and double click on section assignments, select the entire part, press on done and press on OK. Now the section definition to the plate has been assigned, and we want to define a rectangular datum coordinate system, which can be done by choosing this tool and press on continue, and this line would be the x-axis, whereas this would be the straight line in the xy plane. So you can see the datum has been created, and now we have to assign the material orientation. So we go on to the material orientation, and what we do is we select the entire part first, press on done, and then we have to choose the datum, and we can click on the datum that we just created and keep everything as it is. The normal direction is axis 3. Press on OK, and we have assigned the material orientation. Now going on to the assembly environment, double click on instances. So over here keep the instance type as dependent and press on OK. So after the instance has been created, we go back to the paths module and double click on plate. Over here we want to partition the plate in half using the partition face tool, which is basically this one, but we want to choose partition face, use shortest path between 2 points. So if we select this point and create the partition, the single plate has been divided into 2 parts now. Now we go to the assembly module over here, assembly tab basically, and we double click on sets. So we are back in the assembly module, and over here we create a set, and the name of this set can be kept as midspan. Press on continue, and if you choose this line, so this basically is the set of midspan. Press on done. Similarly, we assign sets for end A and end B. So basically this is the end A and this is the end B. So over here we start with end A, continue, select this end, press on done, create another set, end B, continue, press on this, and done. So the end A, end B, and midspan have been defined. Now after that, we want to create a single static general step. So double click on step, and in this dialog box, we name the step as apply pressure and press on continue and press on OK. So since the step has been created as well, we now want to change the default output requests before going on to the boundary conditions and the load module. So what we do is we expand this field output request and edit this. And in this dialog box, what we want to do is uh, we keep everything as it is, but we basically want to have the displacement. So we can turn off the other values, and over here displacement, we can select these displacements. So this is enough since we only need U3 basically. So we can press on OK. And in the history output request, uh, we expand this, edit, and in this dialog box, we only want the midspan. So we go on to the set, and over here midspan, and basically over here we want the displacement as well. So not all the displacements, we can toggle these off and press on OK. So now what we can do is we can prescribe the boundary conditions, and to do that we double click on the boundary conditions over here, and in this dialog box we can name this as rail boundary and choose the displacement rotation type, and the step is obviously initial. Press on continue, and now what we want to do is we assign the boundary condition to the sets rather than to the regions, and so we choose on sets, and in this dialog box uh, we choose the NB first and highlight. If you highlight this, we can see this is the NB, and we press on continue. Now we want to edit the datum and choose this datum and turn on these values, press on OK. Now similarly create another boundary condition for the other end, and which is the end A, and we can write this as fixed end, fixed left end, fixed left basically, initial, and over here continue. So this is the other end, and it press on continue. Again, choose the datum and U2, U3, UR1, UR2, UR3. So press on OK. Now the boundary condition has been applied. Now what we want to do is we want to create a uniform pressure load. So double click on load, and in this dialog box choose apply pressure, and over here select pressure, and we can name the load as basically pressure. So continue, since we want to select both the regions, so we choose shift and then select both the regions, press on done, and over here choose brown, and in this dialog box we put the value as 2 e to the power 4, press on OK. So the load has been applied, and now we create the mesh before defining a job. And to do that, what we do is first uh, we expand the plate over here. It's already expanded, so we double click on mesh. And now since we are in the mesh module, we want to see the part, and over here we put the approximate global size as 0.1. Press on OK and press on done over here. Now next we go on to the mesh controls, select the entire part, press on done. Over here just choose a structured option, press on OK. Now lastly, uh, actually we want to check the element type as well. So go on to the element type, select the region, press on done. Over here, uh, we can, what we can do is we want to have the value rather than S4R, we want to have S8R5. And what we can do is we can choose the geometric order as quadratic and degree of freedom per node as 5. So now we have S8R5, press on OK, done. Lastly, we just mesh the part, press on yes, and the part has been meshed. So now we basically create a job, name this as linear, continue, press on OK. Before submitting the job, let's save the file and we can name this as Skew, press on OK. Submit this and let's wait for the job to finish. The job has been completed. Let's look at the results. So now we are over here in the results module, and if we let's play around to display the element normals and to change the views. So basically we go on to the common plot options. Over here normals, show normals, press on OK. So if you rotate the view, you can see these normals, and next we can change the view. And to change the view, we go over here, view, specify, and choose a viewpoint. So the viewpoint can be put as minus 0.2, comma minus 1, comma 0.8, whereas the up vector can be 0, comma 0, comma 1. Press on OK. So this looks like a nicer view. You can view parallel over here so that we don't get the perspective view. And now we can actually turn on the turn off the normals and press on OK. So next, we can generate the symbol plots of the displacement, and to do that, we go on to the results, and over here in the results field output. So in this dialog box, we choose a symbol variable tab, selected component Q3, press on OK. So if you see it like this, so this is the view. Other than that, so other than that, what we can do is we can make this wireframe, for example. So I think this, yeah, this is the wireframe option. Make it wireframe. Uh, Other than that, we can plot the material directions as well. So we go on again to the result, field output, and over here in the primary variable tab, we select stress. If we have, actually we didn't keep the stress in the field output, so if we had stress values as well, if we chose the stresses as well with the displacements, we would have S over here as well, and we could have plotted that as well. So we didn't do that. uh, we can actually do that as well, and we can do that in the nonlinear model. So other than that, this is the end of the linear analysis part. You can play around, get different values. So at the moment we have the displacement values. Over here in the field output request, if you go over here and if you edit this, and if you select the stresses over here as well, S over here, and if you resubmit the job, you'll get the stress values over here as well. So we don't do it again. So it's pretty simple. Now we'll go on and we'll perform the nonlinear analysis. So for performing the nonlinear analysis, let's copy this model and name this as non. Press on OK. So basically, we only make changes in the step definition. So if you go onto the steps, double click on apply pressure. Over here, we can turn this nonlinear geometry option on. And in the incrementation, we can change the incrementation size as zero point 0.1. Initial incrementation size. Press on OK. So other than that, uh, we can go on to the field output request manager, edit, and over here, what we can do is we can choose the pre-selected ones. Uh, we don't need more than these. We can turn the strains off and also the forces contact. We don't need these values. And so if we keep the domain as the mid span, we can get values for mid span for the plots basically. So we can keep this as mid span. Press on OK, and let's create a job and submit it. So now, since the job has been completed, you can go and monitor the results. You can see the deformation. So what we can do is if we want to check the midspan node, what we can do is, so if we zoom in and over here, if you go on to the query tab, we can choose onto the nodes. And since this is the center, and if we choose this node, for example, it's the first node. This you can see is the seventh node, the eighth node. So these are the nodes on the midspan. Other than that, uh, if you want to plot, uh, if you want to plot a graph, we can basically expand this, and over here we can expand this again, and you can see the history output. So if we go on to the history output, and we want to plot the displacement U3, spatial displacement U3. Uh, so this is a spatial displacement at U3, and basically this was a node 1. So let's do it on node 1. Press on this and show the plot. So this you can see is the plot for the nonlinear analysis. Make a plot of the uh, linear job as well, linear analysis. So let's do that as well. So over here as well, if you go on to the history output and choose the history output. So let's look at the spatial displacement at U3, and let's choose node 1 again for consistency, and let's plot. So at the moment, these graphs look similar, but there is a difference, of course. Next, let's move on to the final phase, which is the dynamic analysis. And to do that, what we want to do is we want to basically copy the nonlinear model, and let's name this as explicit. Press on OK. So over here, we basically need to make some amendments in the material properties. Let's double click on this, and over here we need to add the density of it, which can be 7800, and press on OK. So that's all for the material properties. Now in step definition, what we can do is we can uh, over here, if we double click on if we choose the apply pressure and we want to replace it basically, in this dialog box, rather than static general, we choose dynamic explicit and press on continue. And over here in the edit step dialog box, we can put a time period. We can actually put keep the same time period as 1, and press on OK. And in the field output request, for example, we can make a change, we can edit it, and in this dialog box, we can actually choose the whole model. And over here, we can keep the interval as 200, for example, and depending on what outputs we want, displacement, if you want stress as well, choose the stress as well, press on OK. And likewise, you can get the required output values. So let's move on to the meshing thing. And over here, if we double click on mesh, we are in the mesh module. And over here, if we choose the element type, so what we want to do is we change the element library to explicit. And over here, we keep it as shell, and the geometric order is linear. So press on OK. Now we can create a job and submit it for the dynamic analysis. So the job has been completed. Let's go on to the results. So over here again, you can play around depending on what sort of outputs you require. So this is the deformed shape. Other than that, you can animate this as well. And here's the time history. So there are basically lots of things that you can do. So again, if you want to create a graph, so again, if you want to plot something, so here's the history output. You can go to the history output, and similarly, you can make a plot for, let's try it for U3 at node 1, for example. Let's make a plot, and this is the sort of plot that you see. Again, depending on what outputs you want, you can choose the history output and the field output requests in the model tree, and you can plot graphs accordingly. So this brings us to the end of this tutorial.